I'm Sean Cogan from Harken Industrial, and today we're going to go over some winches, capstan winches, that we're bringing to the market for rescue and rope access specifically. As a sailing company, we've taken a natural progression into other rope handling applications in rescue and rope access and arborist applications like that, where we're seeing a lot of people using winches for hauling scenarios versus setting up a block and tackle system. So this was the first iteration, which is a rigger's winch, more of a utility-based winch for material handling sake. And it's our standard 40, radial 40 deck winch, mounted on its own rigging plate to be able to be adaptable to making different attachment points, anchor points in different areas, different structures. The radial 40 refers to the power ratio that the winch can supply as a force multiplier. So in this winch, being a 40, your maximum force multiplier will be 40 to 1, meaning if you're able to input about 25 pounds of force here, multiply that by 40 and you're hauling 1,000 pounds with just 25 pounds of force input. These are all 2-speed winches, so think of it as high gear, low gear. You're using the leverage of the crank arm as one point of mechanical advantage, and then the gearing as a second point of mechanical advantage. So in one direction, you're getting a faster rope advancement, lower torque, roughly 13 to 1 mechanical advantage. In the other direction, you're getting a lower speed, much higher torque, accomplishing the 40 to 1 mechanical advantage. So with this in mind, we've gone more towards a rescue version. Where comes supplied in this Pelican case. As you can see, it's easy to go in a rescue gear cache. But this version, again, it's a capstan winch mounted on a rigging plate for different mounting options. This one is specifically designed for rescue applications and rope access applications. This plate has been redesigned to be able to fit universally on most tripod manufacturers' makes around the world. Basically anything that you can clamp this onto up to about a 3-inch diameter, this plate will work. This can also be used as a typical rigging plate with carabiner connections, fully rated in all directions. But the big difference here, hence the name Lockhead, we have basically shrouded our self-tailing jaw. This self-tailing jaw is what's going to keep the rope advancing without having someone to manually tail the rope behind the winch to maintain tension. The issue with that in any kind of rescue scenario is that the winch is designed for the rope to release out of the self-tailing jaw very quickly and easily for the initial sailing applications it was designed for. So just in terms of reducing any kind of accident potential, we've been able to shroud that self-tailing jaw so the rope cannot come out without very intentional movements. And it's also made for a controlled lowering aspect of it. If at any point an operator were to come off of the device, it auto locks to block any progression of rope. Where typically lowering on a winch like this, you'd have to untail and then use this more or less as a friction bollard to lower. Here, you more or less just turn the knob forward and it adjusts the spring tension in the self-tailing jaw, so you're still using it as a friction descent or friction managed lower, but you can control all of that just by rotating the head of the lockhead. So with the lockhead kit, it would come as you see it in a Pelican case, ready to go. It will come with your anchor accessories with your mounting plate adapter accessories, some typical steel carabiners. We leave that up to preference in the field, whether you want auto locking carabiners, whatever's good for your department. So it will come with a handle crank, of course, and then like I said, all of your anchoring accessories. Most situations where you'd be using a winch would be in hauling situations. Typically, you're going to be setting up a device for progress capture, and then something to achieve mechanical advantage. That's usually achieved through block and tackle, adding pulleys downstream of your progress capture to be able to lift a load. The benefits of a system like this is that it puts it all in one device. So you have your progress capture, you have your hauling system, and your lowering system all in one place. So it simplifies and cleans up the entire system to where it can be a singular operator type of situation. The big benefit there, obviously, is that the single operator can manage that type of rope handling. So rather than needing 4 to 5 professional rescuers pulling on that rope manually, this would literally replace the strength of what would be equivalent to 4 or 5 grown adults pulling on a rope using a mechanical advantage system. So with a device like this, it's a better allocation of resources to be able to have lesser manpower on teams, so more mobile, nimble teams, and then basically to have responders freed up in case there's another situation, so you don't have all of your technical rope rescue team on one scene. Beyond that, if we're talking about loads that are in excess of a single one-to-one, using the winch, single line to the load, any of that mechanical advantage can still be implemented downstream of this as auxiliary mechanical advantage or power multiplication. So with devices like this, we're looking at the long haul scenarios, the confined space scenarios where you may not have the physical space to operate a full rescue team and the full throw of what a mechanical advantage system in rope needs to actually be pulling the load. So obviously for any mechanical advantage system, whether we're talking 4-to-1, 5-to-1, you're going to be using that same multiplier in rope. So if you're using a 4-to-1, you're going to need to advance 4 times the amount of rope to achieve the lift you're looking for, which is going to require a lot of resets of the system, which adds time to a rescue and obviously manpower. So stay tuned, but we'll take this to a tripod, an artificial high directional, and do a confined space simulation of a haul, a lower, how to rig it, how to set it up on a tripod, and then just go through the general operation of things.